I think each of you must have received a handout. I'm going to talk about that in the end. And today will be the final lecture on mycology. I'm going to talk about opportunistic mycosis, and that actually remains one of the most important aspects of mycology that you as a pharmacist need to know. And just a brief overview of this handout, you will see that we did have 5 lectures on mycology. The first one was pathogenesis of fungal disease, give you an overview as to what pathogenesis is. And remember, that remains the primary objective for each and every microbe that we studied in this course, that you have to know the basic structure of that, because we have to come up with drugs against those structures, cell wall, cell membrane, so on and so forth. Then you have to know about pathogenesis. That again is very important. Unless and until you know about the pathogenesis, you will never be able to figure out as to where drug is acting, why is it acting, how is it causing tissue damage. And then finally, I also wanted you to know epidemiology and clinical features. As far as treatment and preventions are concerned, I just give you a rough idea. Unless and until it's related with pathogenesis, very rarely you are asked any question. The only question you should expect is if there is a drug resistance, if there is a pathogenic factor that's causing the major impact on drug resistance. Otherwise, as far as schedule is concerned, the drug treatment is concerned, their names are concerned, I left it to pharmacologists to take care of that. Okay, so again, this chart will tell you an overview so that you can compare and contrast. That remains the primary objective, and that remains the primary, I would say, a study guide for you to figure out. For example, in this chart, in the flow chart, you see we talked about cutaneous mycosis, and we actually did go through a couple of them. Subcutaneous mycosis, day before yesterday, or was it yesterday? Yesterday, right? We talked about systemic mycosis, and today we'll take opportunistic mycosis. Okay. Now, there was a time, and when I say there was a time, usually you're talking about, sometimes I wonder, it's like 20, 30 years ago, we used to think of Candida only, as an opportunistic infection. But remember, there were quite a few causes that actually led to increased prevalence and incidence of mycotic infection. So there was Candida all in all, and then we came up with opportunistic infection. We used to call them Non-Candida. So there were 2 classifications, Candida and Non-Candida. And by Non-Candida, we were talking about Cryptococcus neoformans. And you remember that was the major organism that we were concerned in AIDS patients. And I kept on repeating myself in order for you to understand pathogenesis of fungal diseases. I want you to go back and read that from the Journal Microbiology, the introduction of fungi, and also some of the chapters that deal with innate immunity and a part of adaptive immunity. So because that's major pathogenesis. So then there came a time that we started talking about non-Candida, non-Cryptococcus. So we're talking about opportunistic infection. They are not Candida and they are not obviously Cryptococcus as well. But there are a group of 2 actually, because I'm not going to go in detail. Aspergillus and Zygomycosis. So these are the 2 important opportunistic infections that we'll touch upon. But remember, if you have a basic concept, you should be able to figure out, especially clinical features are very easy. The moment I say respiratory route, the moment I say lungs, you should pretty much know as to what's going to be happening if any microbe infects lung. Okay. The frequency of invasive mycosis, of course, has increased over the past 2 decades. We did discuss what are the reasons, but always, as I said yesterday as well, suspect fungus if you are dealing with high-risk groups undergoing blood and bone marrow transplant, solid organ transplant, major surgery, and those with AIDS, neoplastic disease, immunosuppressive therapy, advanced age, and premature birth. So these are all high risk factors. Doesn't mean that fungi have to be considered as number one differential diagnosis, but remember that they are considered as one of the important differential diagnoses before you will eliminate the cause or etiology of that particular disease. Now, opportunistic mycosis, basically Candida albicans, Cryptococcus neoformans, and Aspergillus fumigatus. And you can see that is a very, very high percentage, especially the annual incidence of invasive mycosis. Invasive mycosis means that it actually has gone into the system and caused problems. Right? So this will differentiate, and you can see from here the per million numbers of these infections have gone high because of advances that we may have in different aspects of medicine. You can see from here the estimated annual incidence of invasive mycosis to all these pathogens is 72 to 290 infections per million population. And you can see from here, highest still remains for Candida. So Candida again remains as one of the top priority for us to deal, especially when we are talking about opportunistic infection. But that doesn't really exclude neoformans or Aspergillus. They are also there. Again, many a physician, I said yesterday as well, always have a heightened clinical suspicion. Remember we said think fungus, as they used to say think green, so always think fungus, because fungus does remain as one of the very important aspects, especially if you are dealing with managing all those patients. And then another problem is that some of these organisms, and especially Candida, have become resistant as well. So there is a problem with the drug resistance as well, especially if your immune system is compromised. And remember that many times if you are on drugs or you are using other kind of intervention therapies, there's always a danger that we may come across these organisms. So the most important thing you have to consider in these cases is that heightened clinical suspicion. So always think fungus before you send for any test. Right? So don't really exclude it, and don't really always think that, well, the person is normal and the person may be asymptomatic and he or she may be suffering from immunodeficiency. That's most of the time we discover a person having a compromised immune system if the patient suffers from one of these fungal infections. All right? Okay. Now, let's begin with the first one, Candida albicans. That remains again one of the most important opportunistic fungal infection that we're going to talk about. And another important thing for this Candida is that they are also fourth most common cause of nosocomial bloodstream infections. What are nosocomial infections? Yeah. You get it from the hospital. Okay. So remember, because those people that fall in high-risk group, like bone marrow transplant and chronic patients, many of these patients are already attached with the hospital. And all those kind of invasive surgeries are done in hospital. So there's always a chance that these people will pick up Candida as one of the cause of bloodstream infection. And that actually is exceeding any of individual gram-negative pathogens. Remember when we were talking about gram-negative pathogens, we said that that is one of the most important nosocomial infections. But in this case, you should not exclude Candida as one of the causative organisms for especially bloodstream infection, BSI, bloodstream infections. Now, as far as their incidence is concerned, you can see from here the most commonly isolated from the clinical material that actually accounts for 90 to 100, especially from mucosal sites. Because remember we talked about oral flush, especially in AIDS patients. So that's the beginning or vaginal flush. So these are most of the areas where we pick up these Candida infections from. And out of hundreds of species of Candida, which have been described, luckily only few have been implicated in clinical infection, and Candida albicans remains one of the commonest, though there are 4 other species, Candida albicans, glabrata, Candidiasis, and tropicalis. They are also important, especially C. glabrata. It sounds like some kind of a coffee, right? We have all these lattes and all these kind of shakes and, Starbucks kind of stuff. So glabrata can be said to be truly emerging as a cause of BSI. So we are now facing through a problem because we may have either intrinsic or acquired resistance to some of the basic antifungal drugs. Remember I talked about azole drugs. So azole drugs are there, and these are one of the commonly used antifungal drugs. So this is important for us to know that it's one of the emerging cause of bloodstream infection, and it's again one of the species of Candida. Okay, as far as morphology is concerned, again the same rule applies. Remember I said that most of these fungi are dimorphic, right? What does that mean? So they have a capability to exist in 2 different forms, one in the ecosystem and other in the body. So the system in which they live is called saprobic, and once they go into your body, they actually go into parasitic phase. The most important thing that we have to consider in these kind of environment is temperature, and also the morphology as well. Remember, and you can see from this chart as well, some of the fungi are in molds, so they are larger, multicellular. So when they exist in environment, they are multicellular. They produce, all these kind of funny kind of, morphological features. But once they go and invade, they become unicellular and smaller, Conidia, microconidia, so that they can small and go and pass through our mucous membranes. Again, the size typically yeast-like 3 to 5 micrometer, but they do produce buds and blastoconidia. There are some other species, especially glabrata, which also produce pseudo-hyphae and true hyphae. Remember, we talked about true hyphae and pseudo-hyphae. Sometimes they are assembled together, they appear like a hyphae, but they are not true hyphae. Right? And we call them as pseudo-hyphae, and many a time they take a form of a germ tube. And this was one of the first lectures we had for Journal Introduction to Fungal Diseases, if you remember that. Okay, as far as Candida albicans is concerned, they form germ tubes and are terminal thick wall chlamydoconidia. So these are like very small particles that you will see in these cases, and basically you can pay attention to the handout I gave you, and if you see at the bottom of that in opportunistic fungi, you will see Candida albicans, and you see a typical pseudo-hyphae and germ tubes, and these are typical morphological features of these fungi. Now, another important thing I want to discuss today in terms of one of the pathogenic features of Candida is that they have this capability of phenotypic switching. Most of the time they would appear like smooth, white, creamy, dome-shaped colonies. But they can actually change, and one Candida strain can change reversibly into different morphologies. So they can actually change from a typical smooth white colony to a yeast-like, to a cell like very fuzzy and hairy-like colonies. That's another thing, and many scientists and many of the mycologists think that maybe this is also responsible for some kind of intrinsic ability for these fungi to resist antifungal treatment. And that actually comes from phenotypic switching, especially Candida species, are known for that. As far as the frequency of the switching is concerned, is too high. And that's what, if you remember your genetics, we talked about if it's too high, it cannot result from gene mutation, and too low to be attributable to mass conversion. So basically it's somewhere in between. It's not like a mutation purely that we should worry, but there is something there. And most of the time the postulation is that Candida albicans has picked up this quality as a survival mechanism. So it can survive in a different environment. So it can find different kind of comfort zone, comfort micro niches that it can go and kind of get adapted to. And that has also explained why is it very common for human beings to become host of these fungal infections. So this actually is one of they consider as like a master system that these microbes have to not only adapt to an environment, but also adapt in parasitic form within the human body in different forms. So that explains why is it that we are struggling in terms of having this intrinsic or acquired capability to resist antifungal drugs. Now, as far as their epidemiology is concerned, of course, they are known colonizers of human and other warm-blooded animals. Remember, I discussed yesterday that this is not our part of the course to go into zoonotic infections. Basically, those infections that are there for animals, but still you need to know that if a particular human pathogen also happens to cause disease in animals as well. That's what it shows over here. They are found in human, in nature worldwide. The primary site of colonization is from GI tract, from mouth to rectum, so it's pretty much everywhere. Remember we talked about normal flora, so they are there. And if you remember when we talked of normal flora, there was one important thing that we talked about, that there is a fixed number of microbes in our normal flora. So one of the features of maintaining a healthy normal flora is that you keep all those microorganisms in their proportionate numbers. So if you kind of change the number, if you outgrow one, then there always are chances, like Candida, to overgrow and cause problems. So they are commensal, especially in vagina and urethra, on the skin, under the finger toenails. That's a typical area that these are found on human beings as a commensal. And again, they're also there in air, water, and soil. There are estimates that about half of us, about like quarter to half of us, we may have as this species as a normal flora. And again, 70 to 80% of isolates are Candida albicans. Remember, I did talk about all those funny names, Starbucks-like names. You know, all these are important, but this remains as the major culprit in terms of causing human disease. All right? Okay, and this is an important slide for you to know. What does it mean, candidemia? What is candidemia? Just wait a minute, one person at a time. Yeah, thanks. Say it again? When a candida gets to blood. So emia is something in the blood. So remember, we talked about viremia, we talked about bacteremia, and we don't talk about all these like fungemia or mycopenia. So we didn't talk about Candida. So Candida is one of those fungi that are known to go into the blood and cause, infection of the blood. So basically, this will give you an idea as to where do we stand in terms of hospital acquired. And remember I said that why do we have it hospital acquired? Because high risk group of all the patients happen to be in the hospital. So they are chronic patients, solid organ transplant, all those high risk groups happen to be there. Now, some of the high risk groups over here, those people who may have a hematological malignancy. Again, your cells of blood disorder. They again are high risk group. Neutropenia. Why is it important that we consider the number of neutrophils in the body, and why do they constitute as high risk group? Yeah. Sorry. Yeah, they are the first line of defense. The neutrophils are first line of defense, and they are plenty in number. They are part of innate immune mechanism. So if you have something going on, remember we talked about chronic granulomatous disease as well, or if the number are less, then the chances are that you would not be able to control these kind of fungal infections. And gastrointestinal surgery, why gastrointestinal surgery is important for us to consider as a high risk group. I just said that. Yeah. They are the normal flora. You remember I said from mouth to rectum, they're already there. So if you provide these openings and cut and this and that, then there will be a chance for them to go into your system. So they remain as a high risk group. And extremes of age is because of problems with the immune system. Now, they say all admissions have a high risk of all these patients. Then, you can control. You can have no Candida infection. If you do have, all of these are like other important things that you would consider as use of antibiotics. That's going to again change the normal flora. If you're using any kind of catheters like central catheters usually placed in the heart, or hemodialysis, and all these kind of things, especially if you want to make a person stay in ICU for more than 3 days. So all these will enhance the chances of a bloodstream infection, and basically the statistics show 5 to 10 per 1,000 admissions. So very, very high, and unfortunately you can see 12% of those die from underlying diseases. And then again, death due to Candida is very high. So we have about, like I would say, 49%. So half of the patients who come with any other problem and they happen to fall into high risk group, they may end up having Candidemia, and then again, very high incidence for them to basically high mortality they're going to die from. So this is very important for us to consider Candida albicans especially as an opportunistic or nosocomial infection, especially of the bloodstream. Any questions on this one? Yeah.
That's saying that Candida has a 50% mortality rate?
Of all those patients, yeah, of all those patients, they are admitted and they have been diagnosed with Candida infection of the. So out of all those BSIs, bloodstream infection, if it happens to be Candida, 50% of them will die. And again, there are problems. We're going to talk about that, about the intrinsic or acquired resistance to antifungal therapy that we may have. But of course, you can see from here, 12% basically die from underlying diseases as well. So that's again, but 49% basically is death due to Candida BSI. I mean, you do a culture of the blood, you find Candida there, you're trying to treat it, and are unable to manage or treat, and half of these patients die. But remember that we are not correlating that with any of these high-risk groups over there. So any of these high-risk group, if they happen to have Candidemia, the chances are half of them will die. Right? All right. Remember, this is another term, I've been talking about that ever since we started endogenous infection and exogenous infection. I think you are pretty much aware of that. When we say endogenous infection, basically we are talking about those Candida which are already friends with you. They are there as your normal flora. So they take advantage of you whenever you happen to fall in that high risk group, or if you happen to give them permission by any tax patients, anything to enter into your system. Right? So they're looking for this opportunity. They are normal commensal hosts and they're going to go and cause infection. So they remain endogenous source of infection, as compared to exogenous, which be there in the environment. So they are also there, especially, for example, contaminated irrigation solutions. You are treating a patient, IV drips, and many are, remember we have this lab as well. We wanted to make sure that whatever you are giving to the patient parentally is sterile, not only for viruses and bacteria, but also fungus-free as well, especially if they happen to fall in high-risk group. So parenteral nutrition fluid, vascular pressure transfusion, cardiac valves, and corneas. Many other, of course, are there, but you have to make sure that these happen to be one of the commonest source of exogenous transmission of these fungi into your system. Is it clear? You know the difference between exogenous and endogenous? And that's not basically true for fungi only, same for bacteria as well. Remember, we had you complete that exercise to know what is the normal flora of the mouth, of the skin, of the vagina, urethra. You pretty much know that these are going to be held responsible if something happens, that these are going to go and look for opportunity to cause damage, tissue damage. Okay, as far as lab diagnosis is concerned, you need not to know in detail, but remember, for most of the lab diagnosis, microscopy is important. Remember, we talked about the culture as well, and there are some other standard tests. I just want you to know that scrapings basically are one of the important things for lab diagnosis. We have to culture on standard mycological medium, and one of the selective medium is chrome agar. Chrome agar, especially if you are going to deal with Candida, because they form colorful colonies. So you may have, for example, remember we talked about those 4 different types of Candida. They may have a green colony, they may have a blue colony, and they actually based upon, it's kind of a rapid identification tool. You culture them, look at their morphology, and you can pretty much determine as to what is the subtype of these organisms. Okay, so you can see from here, this is a typical isolate on chrome agar. The green colonies are C. albicans. The blue colonies are tropicalis, and the large rough pale are other types of Candida. So this is one of the rapid identification tests that we normally do for identification of Candida. And you can also see, we talked about isotypic, phenotypic switching, so they can kind of switch from a smooth and round colony to irregular kind of a colony here. Okay. Now, in the second group, remember we talked about non-Candida kind of things, and the most important over here is, again, Cryptococcus neoformans. Again, they are there in the environment. They can be found in food and water and can be normal microbial flora. And there's a list of that, opportunistic yeast, but we'll just kind of limit ourselves to Cryptococcus neoformans. And remember, this again is an encapsulated yeast. Encapsulated yeast is distributed worldwide, is present almost everywhere, especially it's been known in pigeon droppings. That's another thing that we want to consider, especially if you have a compromised immune system. And I also want you to pay attention to the handout as well. The most important thing given over here is Cryptococcus neoformans, and you'll see a typical we call it a polysaccharide capsule kind of stuff over there, very obvious as compared to any of other Candida. Okay, if you look at microscope, they are yeast-like encapsulated, typical budding, and again they can also form germ tubes, hyphae, and pseudo-hyphae. But most of the clinical samples would not have that. That's another thing. Remember when we talked about fungi, the challenge we had was that once you take them out of the clinical isolates and grow them on agar, so basically you are trying to mimic a saprobic phase that might not be the tissue or parasitic phase. That always remains a challenge for us to really figure out what will be their morphology if they were to grow on tissues. Cryptococcus neoformans, you see India ink preparation, and you basically see large capsule surrounding budding yeast. So budding yeast, you can see over here, you know, they call soap bubble appearance as well. Typical soap bubble lesions they are called. There are many other tests available. We can do for latest agglutination tests because they have a capsule around them, and then we can also do urease tests. So these are some of the important tests. Of course, they are important when you are dealing with an AIDS patient. Remember, AIDS patients usually do present with secondary infection with Cryptococcus neoformans. Okay. As far as their epidemiology is concerned, well, usually acquired by inhaling aerosol cells from the environment. That actually was pretty much a common mode of transmission for most of the fungi, other than the cutaneous and subcutaneous. When we talk of systemic mycosis and when we talk of opportunistic mycosis, most of the time we're talking about acquiring them through respiratory tract, and they can, from the lungs, they can easily disseminate into central nervous system, and they can actually go and other in very deeper parts of your body as well. And most of the time, if you have a good immune system, normal immune system, your body should be capable to fight these kind of opportunistic infection, and you will really have those kind of diseases which affect for those people who may have, for example, a defective cellular immunity. If a person has a defective cellular immunity, he's going to come up with fungal meningitis. So you can go into the, that's again one of the commonest causes if we happen to be in those immunodeficient, especially defective cellular immunity, because you have, many times these are intracellular. So you also have to have either patent innate immunity or adaptive immunity to fight these fungal infections. Typical natural history, again you will see pigeon droppings, saprobic and parasitic phase. That actually was a common theme for most of the systemic and opportunistic infections, that they are inhaled by aerosol, go into the lungs, and from lungs they can go and travel to different parts of the body. Clinical syndromes, usually a mnemonic process. Again, remember we talked about lymphatic spread and blood spread, but mostly the primary focus is pulmonary, and from there they can be disseminated, but less often. So pulmonary cryptococcosis is variable. So you may have a person presenting as asymptomatic. So it can be asymptomatic, or it can have a very fulminant bilateral pneumonia. Most likely, if a patient presents with fulminant bilateral pneumonia, either he has AIDS or he has inner defect in cellular immunity. Otherwise, we should be able to take care of that. Okay, lab diagnosis, again, you can do a culture. You can look at microscope, especially cerebrospinal fluid, and you will see characteristic encapsulated budding yeast. And many a times, as given in your handout as well, we go for latest agglutination test, because there is a capsular polysaccharide antigen in the serum. That's very commonly done, and we take advantage of the presence of that polysaccharide and do a simple lab test, agglutination test. Because what is an agglutination test? Remember, we did discuss that in immunology as well. Yeah, Ian. So what is, say, capsular polysaccharide antigen? If you have a capsular polysaccharide antigen on any of microbes and you want to go for agglutination test, what is the mechanism of that test? Yeah, what is the basic principle of the test? Test for? ABO blood groups. Nothing to do with ABO blood groups. It's nothing to do with ABO blood groups. Yes, decide. The simple thing is, remember, one of the most specific reaction that we get in immunology is antigen antibody test, right? So if you have an antigen, and if you prepare antibody against this antigen, if you put them together, they're going to agglutinate, as simple as that. They're going to, bond to each other. So, simple agglutination test. You already know the capsule antigen, and if we have prepared antibodies against that antigen, you put them together, you take a serum, you have a prepared antibody, put them together, see under the microscope, and you will see a typical agglutination. Remember, one of the things that when we discussed the properties of antibodies, once they find their corresponding antigen, they're going to agglutinate and bind to that. Okay? All right. The third important opportunistic infection, again, Aspergillus and fumigatus. Remember, Aspergillus, anything that ends with osis, most of the time we're talking about a disease. So osis is basically a disease caused by Aspergillus. And again, it's a broad spectrum of diseases caused by different members of Aspergillus. And many a time, the commonest presentation of this fungus is basically allergic reaction. So that's another important thing that is worth mentioning, especially for this. If you remember, we talked about type 1, type 2, type 3, type 4 hypersensitivity reaction. Which kind of reaction should you expect if you have an allergic reaction to a hypersensitized host, in this case? Type 4. Yeah, who said that? Yeah, good. Simple. Your immune system is used to that, and it's a type 4 type of a tissue destruction that you may get over here. And typically, the reaction is destructive, invasive, or pulmonary, and you may get disseminated disease in highly immunosuppressed individuals. So most of these opportunistic infections, again, are there. And remember, many a times, I keep on repeating again and again, when you have a pulmonary component of tissue destruction, just as we talked about different types of E. coli depending upon their invasiveness. For example, some of the E. coli, pathogenic E. coli, will just limit themselves to the superficial layer. They would not cause bleeding. So there you have to go and penetrate the deeper part of the mucous membrane to go after the blood vessels before they will get a dysentery or kind of blood in the stool. Likewise, in most of the pulmonary infection, if the invasiveness of this fungi is deeper, so you may get blood in the sputum. What is it called clinically? If you expectorate blood in your sputum. What do you call that process? What is it? What is the term used normally if you expectorate blood in the sputum or in cough, to be more specific? Hemoptysis. Good. Hemoptysis. And you can see that written in your handout as well. When you look at Aspergillus fumigatus, you will see a typical radiating spore. Most of the time, presentation is hemoptysis. That will show you the invasiveness of this fungi. Does it make sense? Right? So many a time, the clinical features are very easy for us to determine if we can figure out what is the extent of damage to a particular organ that these fungi are causing. Right? Okay. As far as the epidemiology is concerned, very common throughout the world, and the smaller Conidia particles are already there in air, soil, and decaying matter. And again, we have a challenge in the hospital environment as well. It's going to be again one of a nosocomial infection because you may find them in hospital air, shower heads, hospital water storage tanks, and other potted plants in the hospital. What would you do if you were to keep a patient who is infected with this organism, Aspergillus, in order to protect this person from infection? Like, for example, if you have an AIDS patient, if a severely compromised patient, you want to keep him in the hospital, so what precaution would you take, especially in terms of selection of a room or selection of providing him some kind of disinfection or sterilization? What exactly you need to do?
Don't give that room circulation as far as like air does.
Yeah, so air filtration, very good. Air filtration, because if these Conidia are there in the air, you want to make sure that the air is filtered for these patients. This is one of the important things for those, severely compromised patient kept in ICU. If there is a chance that that particular hospital has had an incidence of having, Aspergillosis in the patient, you want to make sure that the air provided to the patient, is clean of any of these Aspergillus species. Does it make sense? Okay, and then of course, they always do routine testing for shower heads, water, and so on and so forth. Okay, as far as morphology is concerned, again, you can see a typical examination. They can come in different, one of the characteristics of these fungal colonies is that they come in different colors. And I used to wonder, sometimes I used to travel to different parts and see why this water is green and water is blue. I thought there's something to do with the water. Basically, it's nothing to do with the water. It's basically algae growing underneath. So this is like a fungus that gives color. Many a time you will have, brown, green. This is spectrum of color. That actually will give you an idea that basically is a fungus growing. And many a times, if you want to do for definitive identification, you really have to look for those hyphae under the microscope. And some of the conidial heads, I have some pictures for you to look at. You can see from here. That's a typical microscopic examination of Aspergillus fumigatus. So if you see this kind of, conidial head, this is like a conidial head. It's going to go and blow off into the air. And that's like a typical preparation. They call it lactophenol cotton blue preparation. You don't need to know that, but just give you an idea as to what we are talking about in terms of the head of the conidia. So that's where it's going to go and disperse out into the environment, like spores radiating from that. That's another process that is there. There's another picture of that. And you can see all these tiny little spores, once they form, they kind of spread out aerosol into the environment and people can basically breathe in. Okay, then there's a spectrum of diseases caused by Aspergillus. I just want to give you, and this is from your book. Again, you can see it may cause allergic reactions, usually upper respiratory tract. They can basically colonize in your parasinuses and other places. You may have some of the superficial cutaneous lesion, sometime invasive infection, and the most important thing that you want to care is frankly invasive pulmonary infection. That's why one of the clinical features I've put in the handout is hemoptysis. So if a person has a bilateral fulminant pneumonia, it's most likely the person is severely immunodeficient. And unfortunately that may lead to death of the patient. So you have to be careful. These fungi, especially when they are opportunistic fungi, they go into any system, any part of the body and complicate the existing process of the disease. Okay, how do you treat? Basically, you want to keep an eye if you are dealing with those high-risk patients. That's the most important thing, especially neutropenic patients. And obviously we talked about keeping those high-risk patients in facilities where the air is filtered. So you want to make sure that if a person is neutropenic, he doesn't have any innate immunity to fight those infections, and he's going to be susceptible to these systemic, to these opportunistic fungi. And finally, Zygomycosis. Again, this is a group of agents. The most important thing I want you to know in this one is that this actually is more of a chronic granulomatous infection of subcutaneous tissue. Remember, we talked about pathogenesis of fungi, and one of the important things I told you, even in tinea, a typical process where the body wants to limit the spread of a microorganism, and the way body does it to wall off that area to prepare a kind of a shield around that of immune cells, of neutrophils. Many times, if it happens to be bacterial infection, you may end up having pus in the center, like typical granuloma. All the cells of connective tissue are there. But this again will form some kind of a chronic granulomatous infection, and it does occur worldwide, and the common cause again is rhizopus, that you can see also. There are different type of rhizopus, and I actually did have one of the, I usually show it to my students. I am running out of time, so that maybe if I find time next week, I have some clips to show you some of the patients, because these are rare conditions. And one of the patients, he did suffer from invasive zygomycosis, and they didn't realize it, and finally found out it was so invasive, they wanted to do a radical surgery. Finally they ended up removing his eyes, his nose, his mouth, his tongue, everything, so nothing on the face, like a faceless person. So you can imagine the invasiveness of that, and in order to, and there was a classical case, and I think it was on news as well a couple of years, I do have a clip for that. I'll see if I get time to post it to you, or otherwise I'll just post it to you. Okay? Are there any questions? Any question related to this? I'm pretty sure you have a lot of questions in your mind, but any question related to lecture. So that will basically end our series of 5 lectures of mycology. I've got 2 more lectures to go for parasitology, one tomorrow and one on Monday. Right, so that will complete the 15 lectures that were scheduled for this unit. And then again, as I promised, I'm going to go through some of the reviews, especially for biology. And as we discussed yesterday, I found out that many of you may want a little bit of help on how to prepare yourself for these kind of high intensity exams where a lot of memorization takes place. What is it you need to know when you look at those multiple choice questions, and how to attempt, and all that kind of stuff. Are there any other questions that you have in mind? Yeah. Okay. All right. Thank you.